The haptics group is a group of researchers that originally started looking at robot arms and dexterous robot grippers, and over the last 5 years has also begun to look at how human beings can get a sense of touch from things that exist only inside the computer. And so one way to do that is to set up an electromechanical system that you sort of attach one finger to, in our case, that pushes back on you when you touch a virtual object, something that exists inside the computer. One of them, the Phantom, was developed by Thomas Massey, who was a student here, and has gone on to sell these commercially through Sensible Technologies, which is a company that he started.
So what is the Phantom? Well, the easiest way to explain it is that computer monitor lets you see things inside the computer, and speakers let you hear things inside the computer. The Phantom lets you touch things inside the computer. And it's not like a touch screen where you go up and you feel a piece of glass. When you hold the Phantom in your hand, you can actually feel the shape that's on the computer screen, and it feels three-dimensional. If I had my eyes closed, I would swear to you that I was touching something with the end of this pen right now. So the Phantom was really born at the MIT Artificial Intelligence Lab, and the idea came really from robotics. So really, when you look at the Phantom, you can see it's kind of like a little robot arm, except it works in reverse. Instead of moving things around on the table, I'm holding on to the end of this little robot arm, if you will, and touching things that are inside of the computer. And so I started showing the Phantom to doctors that came through the Artificial Intelligence Lab.
The haptics lab at MIT was approached in the summer of 1998 to develop a simulator for laparoscopic surgery. We started with a Phantom device that was developed earlier here at MIT. We have a real laparoscopic tool, just as a surgeon would use. It has all of the same ranges of motion that an actual tool has. These are insertion in and out of the trocar, pitch and yaw rotations about the hole in the person's body, roll around the axis of the tool, and gripping for scissors or graspers, whatever is on the end of the tool.
Surgical simulation depends on knowing what the objects feel like, and the way that we're approaching that is to develop a surgical instrument that can be used in living animals or eventually living people to measure what the different tissues feel like. The device that I've developed is this. I call it the Tempest for Tissue Material Property Sampling Tool, and what it does is makes a very small vibration against the surface of the tissue and measures how hard you're pushing and how far you've vibrated. And by looking at those two things, the force and the position, we can get things like springiness or damping properties of the tissue, and then those can be sent back to the computer to simulate for the doctor to grab a hold of later on.
The power of computers today is more awesome than anybody realizes. And it's a shame that we're still just typing words and doing term papers on computers that are this powerful. They're more powerful than the computers NASA had even 5 years ago, and they're sitting on our desktops. And so we started hiring programmers and decided to write our own software application, and this is called Freeform. Freeform is basically what we call digital clay. It clearly demonstrates how something like the Phantom can be very useful in interacting with the computer. So when people ask me, is the next Phantom going to be a full glove that I can wear or a bodysuit that I can put on? My answer is no, in fact, it's not. We're going to get these things out of the laboratory. It's not going to be some piece of science fiction. It's going to be sitting on your desk. And so our efforts going forward are aimed at getting the technology out to everybody.